All right. So we're going to learn this week how to use the SALT tool for our Module 3 homework as we're looking here. And most of these deal with finding areas under the curve with the normal distribution. So we're going to learn in class kind of how to do this by hand, but this applet can be pretty nice and easy for us just to get these answers done in a relatively quick fashion. So whenever you have a problem that looks like this, SALT is going to open up kind of the same page. There's nothing really specific to the problem as you're looking. So we just want to make sure we know how to use it. All right. So as I'm taking a look here and I click on this applet, it's going to pop up something that looks like this. So this is going to give me options to pick the distribution that I want. For right now, we're looking at the normal distribution. It's going to let me put in what the mean and standard deviation is. And then it's going to let me find different probabilities, whether it's a specific left tail, right tail, two-tailed, whatever. And that's going to be based on what we see over here. If I want a right tail probability, I'd put that. If I want both tails, if I want in between, we're going to have those options right there. So as I'm taking a look at these things, we go back to the problem and it says, find the area between negative 1.23 and 2.64 on the standard normal distribution. So the standard normal is a mean of 0 and a standard deviation of 1. So as we taking a look at this, we can try and say, okay, I want to find specific regions here, negative 1.23, and then I want to find this value here to be 2.64, and that's going to give me the probability that we're trying to find right there. It'll also convert it to z-scores, which this is already a z-score, so that's not a big deal when it comes to that. So that's how we can go about using the SALT tool to help us out on a problem that looks like that. So as we see, we're going to see this showing up a lot. If we take a look at number 14 and 15, they look very similar. The differences here is that it doesn't tell us it's a standard normal, and it doesn't give us Z. So as we're going through these problems here, what we have to do is we just have to put in the appropriate information, and we want to make sure that we're also getting the appropriate region. So if we take a look at number 14, what we're seeing is we're seeing something in between again, just like we did on the previous one. And then when we look at number 15, what we're seeing is something that is greater than. So we're going to take a look at how to do both of those in here. Should be relatively straightforward with it. So if we take a look at that first one, what we would want to do is we would want to update the mean and standard deviation. The problem said they were 6 and 6. And then I wanted to find the area between x is 3 and x is 12. So as you can see, when you take a look at this down here, you see that the mean is 6. That's kind of the center here. So this first one right here is giving us the x distribution, the actual distribution. And the one below it's giving us the standard normal. Either way, I put this in here. I get my probability here, 0.5328. And that's that. So we're pretty good with that. The next one said, right, with a mean of 106 and a standard deviation of 20, what's the probability x is greater than 120? So we would go back and we would do the same thing. We would update our mean. We would update our standard deviation. And then instead of looking at between, we are looking at the probability that x is greater than a specific value. So we're going to end up putting in right-tailed, because that's going to give me that appropriate area underneath the curve that I want. So I type in 120, and then I'll see, and I will see that the area under the curve to the right of 120 is 0.24196. And so we're able to use it in that fashion to kind of help us out as we're going through with these. And so we'll see that most of these tools here end up giving you these specified things here we're going to use this same SOLVE tool. Now let's take a look at a scenario where it says, find z such that 5.9% of the standard normal curve lies to the left. So now we're looking at a scenario where we're kind of working backwards here, where instead of saying, hey, here's my x value, what's my probability? We're going back and we're saying, okay, we're going to find the shaded region such that we get a specified z value when it comes to it. So in this case, it says 5.9% of the data falls to the left. So when I come back here, I want to make this, because I can modify this, 0.059, and it's going to give me the appropriate z value here. So my z-score, in this case, says round to 2 decimal places, would be negative 1.56. So you can play around with this to say, hey, what about in the right tail? Well, if it's the right tail and I want it to be 0.059, then I would get positive 1.56. And so you could play around with this and you could see, hey, what are these interesting values here? Right tail, left tail. Maybe we're interested in both tails, taking a look at that value. We'll see when this might come in handy at some point in this class. So let's take a look and see if there's anything else that I feel like I'm missing as we're taking a look here. A lot of these right here are just problems that you work on and understanding the language of what they mean. So I think that's good enough for y'all to understand how to use the tool. And let's take a look at this one. Suppose X has a distribution with a mean of 80 and a standard deviation of 9 and a sample size of 36. Let's see if this gives us anything. Nah, it just ends up giving us the same thing. So we're going to leave it at that. And hopefully this helps get you moving in the right direction. All right.